In this video, we're going to review functions and what are called difference quotients a little bit. And I want to begin with an example, which says, let g of t be equal to 5t minus t to the third. Part A says, simplify g of 1. Okay, so within the outermost parentheses, I see g of 1. And whatever's inside this parentheses, in this case it's 1, I plug that into my function where my variable is. So I'll get 5 times, and now I plug in the 1 where the t is, minus, and I plug the 1 in where this t is, 1 cubed. So that is 5 minus 1, which is 4. Alrighty, so for our actual expression, we actually want to figure out, well, what is g of 1? But now we know what g of 1 is. We now know that g of 1 is 4. So I'm going to go ahead and write 4 here. So we just need to figure out, well, what is g of 4? So let's plug in 4 in for our variable. So that gives me 5 times 4 minus 4 cubed. And simplifying, this is 20 minus 64, which is negative 44. And that is our answer. Part B now says factor a to the third minus 8b to the third. So before I get into this, I want to review some factoring formulas. And the first one is difference of squares. And that one says if you have x squared minus y squared, this factors. It factors as x minus y times x plus y. And then a difference of cubes looks like x cubed minus y cubed. And then a sum of cubes will look like x cubed plus y cubed. So these formulas, maybe you're a little bit more, a little bit less familiar with. Usually people are very, very comfortable with difference of squares because we see it a lot more often. Difference of cubes, sum of cubes show up less often. So difference of cubes will factor as x minus y first, and then times x squared plus xy plus y squared. And then for a sum of cubes, it turns out it's really similar to a difference of cubes. In fact, there's one tiny change I can make to the difference of cubes formula to make it become sum of cubes. I can just replace y to negative y, or replace y with negative y. And if I did that, this would be x plus y, because that y would become negative y. I'd get a double negative, which would become a positive. Then we'd get x squared minus xy. And then when I plug in a negative y into the squared makes it positive. So I'll still have plus y squared. So that's kind of nice. If I know difference of cubes, I can get sum of cubes really quickly by doing that. Alrighty, so I wanted to review this because this expression can be factored using one of these formulas. So I want you to pause the video at this point for 1 minute. Occasionally during these lecture videos, I'll have you pause the video and give you a chance to try problems. This is really, really important because it gives you a chance to really assess how well you understand the concepts that we've talked about together and how well are you able to apply those on your own. All right, so pause it in 4, 3, 2, 1. Pause the video and try this for about 1 minute. Alrighty, so hopefully you tried it for about a minute. That may not have been enough time to finish the question, but that's okay. I mostly want you to be thinking about, how do I begin? What are the key ideas? Okay, so this is something cubed minus something cubed. Well, what goes in the first parentheses? It's a. It's going to be a cubed. And in the second parentheses, well, what cubed gives me 8b to the third? It would be 2b. So this is a difference of cubes, and if I use my difference of cubes formula, the x is going to get replaced with a, and the y is going to get replaced with 2b. So that'll give me x minus y, which is now going to be a minus 2b, and then times x squared, that'll be a squared, plus xy will be a times 2b, and then plus y squared, which will now be plus 2b quantity squared. All right, and then I can simplify this a little bit. This gives me a minus 2b times a squared plus 2ab. And then when I square the 2b, I get 4b squared. All right, and that is as far as I can go with factoring this. When we do difference of cubes and sum of cubes, the three terms that we are left with in this last parentheses almost never factor further. All right, so I want to do one final part to this example. Part C says simplify g of 2b minus g of a all over 2b minus a. So this fractions of this form are called difference quotients. And we will see these a lot in calculus, especially in the early going. They appear in what's called the definition of the derivative. We don't need to know what the derivative is to be able to answer this. This is purely going to be some algebra and pre-calc. So let's see how we can tackle this. So remember, with a function, whatever's in the parentheses, I plug that in for my variable. So with this first term, I see a 2b in the parentheses. So I'm going to plug that in wherever my variable is. So I'll get 5 times 2b minus, in parentheses, 2b cubed. And then I have minus g of a. So I got to make sure I subtract all of g of a. So I'm going to make sure I put a bracket so I don't forget to distribute that negative. And now I'm going to plug in a for the variable. I'll get 5a minus a cubed. So this whole thing over 2b minus a. So now if I simplify the top a little bit, I get 10b minus 8b to the third. In distributing the negative, we get minus 5a plus a to the third over the 2b minus a. So now the denominator is pretty simplified. Let's focus our attention on the numerator. And with the numerator, we have 4 terms. So in general, when we have 4 or more terms, and I may need to do stuff like factor, usually what we'll try is to factor by grouping. Okay, so this is really a throwback to algebra here now a little bit. So let's try to factor this by grouping. So I'm first going to try it. I'm going to call this attempt 1. It turns out attempt 1 won't work, but let's see why. Okay, so I'm going to write 10b minus 8b to the third minus 5a plus a cubed. Let's try to factor this. So when I group it, let's first try to just group the first 2 terms together. I'll put a under brace below them, and then the last 2 terms together. I don't want to just put parentheses around these and do like a 10b minus 8b cubed times everything after that, because that changes the meaning. If I put parentheses around them, it means I want to multiply the first group times the second group, and that's not the same thing as what this is saying. Okay, so I don't want to put a parentheses. So I like to indicate my groups by putting these little brackets or braces underneath my groups. So now let's try to factor the first group. I notice that 2b is common to both of those terms. And if I take that out, I'm left with 5 minus 4b squared. From the second group, I can take out a. Maybe if I wanted to take out negative a, I could. If I took out negative a from the first term, I'm left with 5. From the next term, I'm left with minus a squared. And at this point, I notice that when I look at this first group and that second group, there are no common terms. No common terms. And if there are no common terms, that just means that this is, it is an incorrect grouping. It doesn't necessarily mean that it doesn't factor. It might factor, but maybe we just got the wrong grouping. Incorrect grouping. Okay, so let's try this differently. Okay, so I'm going to call this next attempt 2. All right, so I'm just moving things over a little bit to give myself more room. All right, so attempt 2. Let's try to group things differently. So if I look at these terms, keeping in mind how we factored part B, that difference of cubes, let's put the a cubed and minus 8b cubed together. So let's try putting these 2 together, and then we'll try keeping these 2 together. Okay, so now I will have the plus 10b minus 5a. Because we already saw how to factor these first two. It was a difference of cubes, and that factored as a minus 2b times a squared plus 2ab plus 4b squared. Remember, we did that in part B. Okay, and now for the last two terms, what could I take out? I could take out a 5. It turns out it's a little bit nicer if I take out negative 5. If I take a negative 5 from the minus 5a, I'm left with a. And from the 10b, I'll be left with minus 2b. And that is super nice because now I notice a minus 2b is a common term in these two spots. So I can factor that out. Let's factor, let me put it in a different color. Let's factor out that a minus 2b. And that'll leave me with a squared plus 2ab plus 4b squared. That's what's left over from the first term. From the second term, I'll be left over with that minus 5. All right, so that is how we factor this numerator using grouping and some difference of cubes. So now I got to put it together. So therefore, putting this together, we had 10b minus 8b cubed minus 5a. Oops. Sorry, one more time. When I write it out, we have 10b minus 8b cubed minus 5a plus a cubed, that whole thing over the denominator, which was 2b minus a. Now I know how the numerator factors. Factors is a minus 2b times the a squared plus 2ab plus 4b squared minus 5. Let's write this a little bit better. That's a minus 2b. And I notice this is almost going to cancel the denominator. The denominator is just exactly the opposite in sign from a minus 2b. But I can fix that if we just factor a negative from the denominator, because that'll give me a minus 2b left over. All right, and now I see that the a minus 2b on top will cancel with the one on the bottom because now it's been factored out completely. And so that will leave me with minus, parentheses, a squared plus 2ab plus 4b squared minus 5. One super important thing about this is, if I think back to my original expression that I was trying to simplify, notice that there was this denominator, and when I have a denominator, I got to make sure that the denominator is not 0. And as long as the denominator was there, it's clear that the denominator shouldn't be 0. But as soon as it disappears, once it canceled, that denominator disappeared, I have to make sure that I don't change the domain. So I'm going to make sure that I include the fact that a cannot be equal to 2b. Because if it was equal to 2b, it would have made my original denominator 0, and that can't happen. It would have made the whole thing undefined. Okay, so this whole thing, including this domain restriction, a is not equal to 2b, that is my answer. So the quick kind of rule about this, and when do we put this in, is when we're simplifying something and the denominator cancels, when we're simplifying an expression, the denominator cancels, we must include the domain restrictions. Because when I simplify a function, the domain needs to stay the same. So initially, a was not allowed to be equal to 2b. So even after I cancel it away, the a better not be equal to 2b. So I need to explicitly write that in, because just by looking at the simplified form, I couldn't tell that a was not supposed to be 2b. That's why I have to put it in. So in terms of our goals, we finished our second goal, which is to review factoring.